The hash. Getting my hash brown on. Smoking my... Oh, wait a minute. Nope, wrong hash. So when we're talking about hash, we're typically talking about how the passwords are actually stored on the systems. Now, obviously, if I had a file that stored usernames and passwords and it was completely clear text, there would be no use for having security, right? Because anybody could find that file. You remember that SAM database? Well, it stores user accounts and passwords in what they refer to as a hashed format. Now, back in the day, Microsoft used something called LM hash, which, oh man, what a nightmare. And sometimes still today, it is a nightmare. And I get this all the time whenever we teach ethical hacking. It's like, why do you talk about passwords and all this stuff with older OSs? Why not be talking about the new stuff? Well, I'll be honest with you. It's almost like a hunter. If I'm going to go out and hunt my prey, I'm not going to go out after the latest, newest target out there. I want to go after the oldest. It's slower. No one's paying attention to it. Who knows if it's been updated? The newer stuff has newer technologies and sometimes makes it harder for me. And trust me, I just taught a class 2 weeks ago. And in the class were 2 IT guys from a huge state organization. And as we were talking, they told me, yep, they still have some XP machines and some Server 2000 and 2003 systems. Now you may be shaking your head, but again, why would I upgrade a machine that does one task? In their case, it handled their imaging system for documentation. We see this all the time also, like in manufacturing facilities where there's a robotic arm that just goes back and forth all day long and it's being controlled by a Windows machine. Does it need to have Windows 10 on it? It works fine with XP. So what would happen is that if you created a password that was 14 characters or less, we would actually take that password. We'll say it was Batman Rules because obviously that should be a password that everybody uses. No, what would happen is LM hash would then go through and take all the letters, didn't matter if you had upper and lowercase, but it converted it to all uppercase. After it converted it to all uppercase, it then padded any leftover fields so that it filled out all 14 characters. So in this case here, I'd have 3 padded spaces. Then things got kind of crazy. LM hash then went through and split up the password into 2 7-character strings. The 2 7-character strings were then encrypted and then combined back together. So as an example, Batman R would be hashed out to this value, and the leftover ools with its padded spaces would be encrypted to this hash. Then they were combined together, and that would be your LM hash. Microsoft then added NTLM, which is the NT LAN Manager hash. So the result that we would see inside of the SAM account database included the user's name, in this case here, B. Wayne, a number listed after his name, and we'll talk about that one here in just a second, followed by the next 32 characters, which was the LM hash, and then they appended an NTLM hash. Now, the big difference between these two was in the password hash algorithm. LM used what they referred to as DES, which was very easy to crack. Then they came out with NTLM version 1, which got us to using MD4, which was a better algorithm, but NTLM version 2 used MD5, which is even better, and technically you should use it whenever possible. So then you might see another account listed in there as administrator followed by 500. That number, remember I told you we'd talk about that number? Anybody remember from enumeration what that number represented, especially on an administrator account? 500. Yeah, that's the SID. All administrative accounts in the Microsoft world ends with a 500 at the end of the SID. And again, I would see a combination of the LM hash and the NTLM hash. Here's another one. Gee, I wonder what the password is. Okay, now some notes here for you. Anytime you see a hash that ends with a AA, D3, B4, 35, B5, 1404, EE, this should mean something to you. And you're like, Dale, I'm not a dork. No, this is a very, very common ending hash. And what it means to you is this, is that the last 7 characters, remember we have to pad it to make sure we equal 14 characters? This tells me that a password is 7 or less characters in length. Now something similar happens if somebody types in a password that's over 14 characters. Remember we told you this is what all happens with 14 characters. Well, if it's over 14 characters, then the LM hash value is dumbed. It's not even utilized. In fact, that's how we used to teach people to bypass the LM hash environment, is that you had to create a password over 14 characters. Operating systems today, since Vista and higher, have the LM hash turned off. So you might see this one quite a bit.